Dzień dobry, witam serdecznie Państwa na dzisiejszym rodeo. Jest to pierwsze rodeo. Jestem inżynierem sprzedaży tu w SUSE. Jesteśmy tutaj również w sali z uczestnikami na żywo, dlatego będziemy tutaj troszkę duplikować ten nasz przekaz. Jest ze mną Rafał Kruszewski, nasz kolega, nasz dyrektor marketingu, i będzie współprowadził ze mną nasz inżynier z Niemiec, Jan Bruder. Jan, do you want to say hi?
Yes, hello everyone. I think you say dziękuję za. Oh, now I forget everything. I want to say something smart in Polish, but it's fine. Zaproszenie. Dziękuję za zaproszenie. Okay, so my name is Jan Bruder. I'm with SUSE, part of the Kubernetes team there. And yeah, I'm looking forward to work with you today here in the workshop.
Excellent. Thank you, Jan. Jan dołączy do nas w dalszej części. Natomiast pierwszą część poświęcimy, właściwie to pokażę nas najpierw, bo o tym zapomniałem. Natomiast co dzisiaj będziemy robić? Plan jest taki, że pierwsza część będzie polegała na objaśnieniu Dockera i podstawowych pojęć Kubernetesa, po czym przejdziemy do narzędzia o nazwie Hobby Farm, gdzie każdy z nas dostanie konto użytkownika i swoje wirtualne maszyny, gdzie będzie można zainstalować Ranchera, zdeployować naszą pierwszą taką aplikację typu Hello World. Jeśli się uda, to też coś troszkę bardziej zaawansowanego typu stanowa aplikacja zobaczymy. I na końcu będzie część przewidziana na pytania, dyskusje. Więc tak, żeby ustalić oczekiwania, dzisiejsze rodeo jest pomyślane dla tych, którzy są relatywnie nowi do Kubernetesa, dla których Rancher jest czymś dość nowym. Jakby będziemy tu mówić o pewnych nieco bardziej zaawansowanych rzeczach, jeśli się uda, ale raczej się nastawiamy na to, żeby przywitać tu nowe osoby w konteneryzacji. I taka uwaga, że to w jaki sposób to będziemy robili, to demo nie jest koniecznie tym, jak zalecamy, żeby to robić na produkcji. Mam nadzieję, że to oczywiste. Co będzie nam potrzebne do tego, żeby skorzystać w pełni z dzisiejszego rodeo, to przede wszystkim, a właściwie tylko aktualna przeglądarka Chrome, Firefox albo inne przeglądarki oparte o Chromium. Jeśli mamy jakieś pytania, osoby z sali naturalnie mogą pomachać i wtedy do nich podejdziemy. Natomiast osoby online prosimy, żeby korzystały z narzędzia Questions w panelu GoToMeeting i to w ten sposób można nam tutaj zwrócić uwagę, że jest jakiś problem, albo po prostu się dowiedzieć więcej na jakiś temat. Od razu podaję linka, żeby sobie zawczasu otworzyć, ale ten link będzie powtórzony, więc nic się nie stanie, jeśli go teraz zignorujecie. learn.eu.hobbyfarm.io to jest ten adres. I przechodzimy do właściwej części, czyli do tego wstępu na temat podstawowych pojęć kontenerowych, kubernetesowych, tak żebyśmy też wiedzieli, co właściwie robimy już w tej części praktycznej, żebyśmy trochę rozumieli. Wiem, że tu na pewno na widowni tutaj z nami są osoby, dla których to będą oczywiste rzeczy, pewnie wśród Państwa tam online również, ale wybaczcie, dziękuję z góry za cierpliwość. Po prostu nie wszyscy są już tak zaawansowani, a chcemy też właśnie zachęcić nowe osoby do wejścia w ten świat. Więc po pierwsze, kontenery są świetne. Wiemy, że umożliwiają przepraszam, właśnie mi się niechcący rozłączył mikrofon. OK, chyba z powrotem jestem. Więc kontenery są świetne. Wiemy, że umożliwiają tworzenie aplikacji w architekturze mikrousługowej, że umożliwiają izolację dla naszych workloadów, znaczy takie izolowane, czyste środowisko dla poszczególnych naszych tych aplikacji czy serwisów, że są przenoszalne, więc można łatwo migrować je na inne środowiska, na chmurę czy gdziekolwiek. I łatwo też można dzięki nim skalować aplikacje. Więc kontener, najprościej rzecz ujmując, jest działającą instancją obrazu kontenerowego. Czym to się różni od maszyny wirtualnej? Tym, że jest to wirtualizacja jakby jedną warstwę wyżej niż maszyny wirtualne. Maszyny wirtualne wirtualizują hardware, natomiast kontenery wirtualizują system operacyjny. Czyli krótko mówiąc, kontenery współdzielą jądro systemu operacyjnego. Nie ma potrzeby w przypadku kontenerów budowania całego kompletnego systemu operacyjnego, jedynie się powołuje zasoby, które są potrzebne dla danego serwisu, dla danej aplikacji. W jaki sposób powstają obrazy kontenerów? Buduje się na podstawie obrazu bazowego i dodając do tego zbudowany kod aplikacji wraz z zależnościami, które te aplikacje mogą potrzebować, tak żeby ten kontener zawierał wszystko, czego dana aplikacja potrzebuje do działania. Budowanie takiego obrazu odbywa się, no przynajmniej w tym tradycyjnym ujęciu, teraz już są dostępne inne też metody, ale tradycyjnie przy pomocy Dockera budowanie wygląda w ten sposób, że definiujemy plik Dockerfile, który jest takim przepisem na to, co ma zawierać nasz obraz kontenerowy. I tutaj widzimy od góry from, jest to określenie obrazu podstawowego, właśnie tego base image'a. Label jest opcjonalny, ale bardzo przydatny. Potem możemy, jeśli chcemy, dołożyć polecenia, które mają być wykonane na takim właśnie bazowym image'u. Możemy określić pliki, które mają być przekopiowane z naszego katalogu docelowo do takiego obrazu kontenera, określić katalog roboczy i też określić port, który ma być otwarty i komenda, która ma być wykonana podczas uruchomienia takiego obrazu. Więc tak w skrócie to oczywiście to nie jest kompletna lista, ale to jest przykład, jak taki obraz kontenera, w tym wypadku Apache'a, można powołać. I uruchomienie kontenera polega na tym, że odkłada się kopię jakby od takiego image'u, od takiego container image'a, która następnie dostaje swój zapisywalny kawałek przestrzeni dyskowej, no i właśnie zostaje wykonana ta komenda, którą zapisaliśmy jako tą, którą należy wykonać przy uruchomieniu. Więc to jest główna różnica pomiędzy obrazem a kontenerem. Kontener jest tą działającą instancją obrazu. Obrazy kontenerów dystrybuujemy przy pomocy czegoś, co nazywamy rejestr kontenerowy. W przypadku tej tradycyjnej takiej ścieżki dockerowej używamy poleceń takich jak docker build, czy pull, czy run, gdzie możemy właśnie przy pomocy tych poleceń dockerowych zaciągać kontenery, czy uruchamiać, czy je właśnie budować i zamieszczać w rejestrze. Taki rejestr, jest ich kilka, oczywiście takich już gotowych, z których możemy korzystać. Najpopularniejszym zdecydowanie jest Docker Hub, ale też wszyscy dostawcy chmurowi oferują swoje też rejestry i naturalnie można stworzyć sobie swoje własne on-prem, więc mamy też właśnie prywatne czy chmurowe. Niektóre rejestry udostępniają pewne rozszerzone funkcjonalności. Taki podstawowy rejestr dockerowy jest dość ograniczony w funkcjonalnościach, natomiast są bardziej zaawansowane opcje, takie jak Harbor, które też udostępniają wiele innych potencjalnie pożytecznych funkcji, takich jak skanowanie pod względem podatności, czy audytowanie i tak dalej. Więc tak, no mamy kontenery, mamy rejestr, gdzie je przechowujemy i dotarliśmy do etapu, gdzie uruchamiamy sobie te kontenery, coś w nich działa, no i świetnie. Zarządzanie kilkoma takimi kontenerami, żaden problem. Ale bardzo szybko takich kontenerów się robi bardzo dużo. Zazwyczaj nawet proste aplikacje się składają z przynajmniej kilku, ale często nawet kilkudziesięciu mikroserwisów. Do tego mogą być różne wersje tych kontenerów i no, każdy z tych kontenerów wymaga odrębnego zarządzania, w sensie sieci, jakiejś może automatyzacji, bezpieczeństwa i tak dalej. Robi się to bardzo trudne, bardzo złożone. Więc do tego powstały rozmaite jakby systemy do zarządzania kontenerami, spośród których, jak wiemy, tę wojnę standardów wygrał Kubernetes. Mieliśmy tam jeszcze kilka innych opcji, był Docker Swarm, znaczy no istnieje dalej, ale już mało kto właściwie korzysta. No Kubernetes jest tym de facto standardem obecnie. Czym się charakteryzuje Kubernetes jako platforma? Przede wszystkim jest open source'owy, więc mamy pewną gwarancję takiej otwartości i tego, że ten standard pozostanie w działaniu przez jeszcze długi czas, że nikt go nie zamknie albo nie zrobi z nim czegoś niechcianego. I Kubernetes charakteryzuje się tym, że korzysta z deklaratywnej konfiguracji. To znaczy, że deklarujemy, jakbyśmy chcieli, żeby było, a następnie ten engine kubernetesowy doprowadza do tego, żeby stan faktyczny był zgodny z tym, co my zadeklarowaliśmy. I kolejną cechą Kubernetesa jest to, że w Kubernetesie wszystko jest zasobem i wszystko jest adresowalne poprzez API, co ma pewne konsekwencje względem tego, jak wchodzimy w interakcję z takimi właśnie zasobami klastrowymi. Ale o tym jeszcze za chwilkę więcej. Więc generalnie na każdym zasobie można dokonywać operacji takie jak utworzenie, aktualizacja, usunięcie i tak dalej. I wśród tych zasobów właśnie omówię troszkę te zasoby, przynajmniej te najważniejsze, bo jest ich dość dużo teraz, nie mamy czasu na to, żeby wszystkie omawiać. Zresztą to nie jest miejsce na to. Raczej chcemy tutaj takie wprowadzenie zrobić, żeby wyjaśnić te podstawowe rzeczy. No więc podstawową najbardziej jednostką w Kubernetesie jest pod, jest najmniejszą jednostką taką deployowalną. Można powiedzieć, że w pewien odległy sposób jest to coś w rodzaju wirtualnej maszyny w świecie hypervisorów, tyle że kontenery są zwykle znacznie mniejsze i często też realizują funkcje, które są mniejsze w zakresie, są bardziej granularne. Ale niekoniecznie. Mogą też być bardzo duże kontenery i zawierać całą na przykład bazę danych SAP HANA. Więc pod zazwyczaj zawiera jeden kontener, ale to też nie jest sztywna reguła, może zawierać więcej kontenerów, jeśli są one ściśle powiązane i jest to korzystne z jakiegoś powodu. Podowi pod ma swoje własne zasoby, w sensie storage sieci i pod jest przy pomocy schedulera jest uruchamiany na nodach typu worker. Kolejnym zasobem, jaki spotykamy w Kubernetesie, jest deployment. Deployment bardzo się przydaje, kiedy chcemy uruchamiać kilka kopii identycznych podów, bo naturalnie Kubernetes sam z siebie by nie wiedział, że pod X, pod Y i pod Z są tak naprawdę kopiami tego samego kontenera, więc deployment powoduje, że można je w taki wygodny sposób zgrupować i zarządzać nimi właśnie jako grupą, gdzie wiadomo, że to są identyczne kontenery, które realizują tę samą funkcję. I wtedy w łatwy sposób można skalować, czyli po prostu tworzyć dodatkowe kopie albo je usuwać. I też przydaje się to do wdrażania update'ów czy też rollbacku. I taki deployment jest definiowany, tak jak większe rzeczy w Kubernetesie, między innymi jest określany przez YAML, gdzie możemy określić właśnie na przykład liczbę replik, tak jak to widzimy na tym zaznaczonym obrazku. I teraz, jeśli się zdarzy, że się nam któryś kontener wysypie, zniknie, wtedy dostajemy Kubernetes orientuje się bardzo szybko, że stan faktyczny się nie zgadza z tym pożądanym, że nie mamy pożądanej liczby 3 replik i wtedy uruchamia się proces właśnie taki schedulingu, gdzie dodatkowy taki pod zostaje powołany na miejsce tego brakującego. I w ten sposób mamy przywrócony stan pożądany. Również do tego, żeby żeby ułatwić zarządzanie czy orientowanie się w tym, co zdeployowaliśmy, bardzo przydaje się zasób o nazwie service. Tu należy rozróżnić zasób kubernetesowy o nazwie service od takiego ogólnego hasła, które po angielsku znaczy usługa. Service tutaj mówimy wąsko w kontekście właśnie zasobu Kubernetesa. Co robi serwis? Serwis sprawia, że mamy jeden statyczny, adresowalny punkt, do którego możemy się odnosić, jeśli chcemy zrealizować jakąś funkcję, jakąś usługę. Bo pody ze swojej natury są śmiertelne, są jakby zaprojektowane w ten sposób, żeby łatwo było je usuwać, łatwo było je powoływać, więc naturalnie ich adresy IP też się zmieniają. I serwis dostarcza takiego właśnie statycznego punktu odniesienia, gdzie możemy właśnie odwoływać się do serwisu, a serwis już będzie wiedział, które pody realizują właśnie tę daną funkcję. Tak najogólniej mówiąc. Serwisy mogą być zwrócone do wewnątrz, takie jak cluster IP, albo zwrócone na zewnątrz klastra, takie jak nodeport albo load balancer. Te, które są zwrócone do wewnątrz klastra, no to wyglądają troszkę tak jak to na obrazku, gdzie mamy jeden adres IP serwisu i możemy się do niego odwoływać również właśnie po serwis DNS-ie, a w backendzie mamy pody z jakimiś swoimi IP, z jakimiś swoimi właśnie ustawieniami i przy pomocy tych między innymi przy pomocy labels, czyli etykiet, możemy się orientować, które są do czego. Natomiast jeśli chodzi o serwis zwrócony na zewnątrz, idea jest w zasadzie taka sama, czyli user jest tutaj na tym obrazku kimś albo czymś, może to być inna usługa, która się podłącza z zewnątrz i odpytuje serwis, natomiast serwis przekierowuje to do jednego z podów, o których wiadomo, że żyją aktualnie i że realizują właśnie te funkcje. Właśnie do tego się przydaje deployment, bo deployment właśnie grupuje pody, które wiadomo, że mają te same funkcje. I to jest, nawiasem mówiąc, dobry powód, żeby zawsze tworzyć deployment, nawet jak się planuje użycie tylko jednego poda, bo jak się ma deployment, to wtedy można użyć serwisu. I podobnie jak w poprzednim przypadku, jeśli serwis wykryje, że któryś pod zniknął nam, po prostu się zatrzymał albo został usunięty z jakiegoś powodu, to naturalnie przestaje kierować do niego ruch i kieruje tylko do pozostałych. Natomiast jeśli właśnie na przykład w wyniku autoleczenia kubernetesowego ten pod zostanie przywrócony, ale już z innym adresem, serwis też natychmiast będzie wiedział, pod jaki adres ma kierować. Więc to jest przydatne właśnie, żeby mieć punkt odniesienia z zewnątrz. No dobrze, przechodząc dalej. Dostałem sygnał, że mnie nie słychać. Czy możecie, Państwo, którzy są online, możecie napisać na czacie, czy słychać? Mamy już potwierdzenie, słychać. Dobra, okej, dzięki. Super. Okej, bo ja się też trochę wystraszyłem, bo ten kabel mi tu wypadł i już, no wiecie, stres. Więc dobrze, wróćmy do Kubernetesa. Kubernetes i obiekt czy resource, zasób o nazwie ingress. Ingress spełnia taką funkcję, że daje serwisom, no między innymi jedna z funkcji jego, daje serwisom adresy URL, które można z zewnątrz osiągnąć, czy do których można się dostać z zewnątrz, ale realizuje też wiele innych funkcji. Właśnie może służyć do load balansowania, może służyć do terminowania ruchu SSL, albo też na przykład do name-based virtual hostingu. Tak jak na tutaj kolejnym moim slajdzie, gdzie mamy odwołanie, które w zależności od tego, co wpiszemy w adresie, czy wpiszemy foo.bar.com/foo czy /bar, to w zależności od tego ingress przekieruje na ruch na serwis A albo na serwis B. To jest jedna z możliwości wykorzystania ingressu. I tak jak widzimy, tutaj te serwisy mogą też od razu być zdefiniowane z różnymi portami i innymi ustawieniami też. Oprócz tego mamy w Kubernetesie wiele innych zasobów, wiele innych resursów. Myślę, że każdy, kto będzie działał z Kubernetesem, czy już działał, zetknął się też z sekretami, czyli zasobami do przechowywania takich rzeczy jak certyfikaty, czy innych takich związanych z bezpieczeństwem. Mamy też zasoby o nazwie persistent volumes, które służą do tego, żeby zapewniać naszym podom jakiś trwały storage, który nie zniknie wraz ze zniknięciem poda. Stateful sety przydające się do baz danych kubernetesowych i tak dalej, i tak dalej. Mamy tego sporo, ale no, tak jak mówiłem, to już na inną okazję. Jeszcze dwa słowa o architekturze Kubernetesa. Kubernetes tak na bardzo takim ogólnym poziomie jest zaprojektowany tak żeby żeby istniały 3 plany, takie nazwijmy 3 warstwy. Control plane, plan kontrolny, który zarządza klastrem i udostępnia API właśnie do sterowania tym klastrem przez użytkowników. Ten węzeł, który realizuje te funkcje, zazwyczaj tradycyjnie się nazywa master. Ten węzeł korzysta z bazy danych o nazwie etcd, która jest miejscem przechowywania wszystkich informacji o stanie klastra. I mamy też warstwę workerów, czyli to są węzły, które realizują faktyczne workloady, to na nich są uruchamiane te pody, które są faktycznymi workloadami, które nie są systemowymi podami. Baza danych etcd często jest uruchamiana na tym samym nodzie, na którym jest powoływany control plane. Wtedy to się też nazywa już jakby zbiorczo master node. I jeśli chodzi o instalację Kubernetesa, no jeśli by ktoś się podjął instalacji taką tradycyjną metodą od zera, no jest to wyzwanie. Jest to długi proces i skomplikowany dla zainteresowanych. No to jest też ciekawe ćwiczenie z Kubernetesa. Kelsey Hightower udostępnia repozytorium, gdzie można właśnie krok po kroku postawić sobie Kubernetesa tak ręcznie, ale no to jest trudne. Znaczy, przede wszystkim nikt tak nie robi, bo tak jak i dystrybucji Linuxa się nie kompiluje od zera zazwyczaj, tak jak w przypadku Kubernetesa używamy zazwyczaj gotowych dystrybucji. I mówię to dlatego, żeby trochę tak zaprezentować czy zachęcić do tego, żeby przyjrzeć się naszej dystrybucji o nazwie RKE, Rancher Kubernetes Engine. Czym ona się odróżnia? Dlaczego do niej zachęcam? Jest to 100% upstreamowy Kubernetes. Nie ma tam nic takiego customowego, co by mogło spowodować jakiekolwiek problemy później. Jest oczywiście certyfikowana przez fundację CNCF. Charakteryzuje się tym, że jest bardzo łatwy w instalacji, głównie dzięki temu, że RKE swoje usługi trzyma w kontenerach Dockera. Więc jakby same właśnie elementy składające się na Kubernetes, same usługi Kubernetesa są w kontenerach, więc mamy taką trochę incepcję kontenerową. I dzięki temu instalacja jest bardzo łatwa, jest bardzo szybka. Dzięki temu możemy łatwo upgrade'ować takiego Kubernetesa, łatwo podnosić jego wersję, bo możemy zrobić taki rolling upgrade, właśnie gdzie podnosimy jedne kontenery, a inne gasimy. To sprawia, że również backup i potencjalny disaster recovery jest ułatwiony, bo zwłaszcza w połączeniu z Rancherem dostajemy opcję właśnie łatwego backupowania stanu takiego klastra. Sprawia to też, że instalacja AirGap jest bardzo prosta, bo tworzymy sobie tylko lokalne repozytorium z odpowiednimi obrazami kontenerów i możemy stawiać takiego Kubernetesa bez internetu. No i wreszcie, zmierzając do sedna sprawy, klastry Kubernetesa są świetne, ale to już gdzieś widzieliśmy taki podobny slajd. W dzisiejszym świecie rzadko się kończy na jednym klastrze. Nawet najprostsze deploymenty mają przynajmniej te 3 klastry, dev, test i produkcja, a zazwyczaj w praktyce to się mnoży jakoś tak dziwnie. I mamy też być może różne lokalizacje, być może chmurę, być może jakieś disaster recovery. I krótko mówiąc, szybko się takie Kubernetesy robią dość rozległe i się tak właśnie rozprzestrzeniają nam, co sprawia, że indywidualne zarządzanie takimi klastrami też się robi problematyczne. W sensie, żeby upewnić się, że na każdym z tych klastrów jest odpowiednia polityka bezpieczeństwa i że odpowiednie osoby mają odpowiednie dostępy i że wszystko, co trzeba, żeby tam instalować na nich, no, robi się to, oględnie mówiąc, kłopotliwe. I właśnie do tego został stworzony Rancher, żeby dokładnie ten problem rozwiązywać, czyli żeby zarządzać Kubernetesem wszędzie, niezależnie czy to jest w naszym data center, czy to jest w chmurze, czy już mamy Kubernetesy w Edge'u. Rancher dostarcza pewien zestaw funkcjonalności, który bardzo ułatwia nam właśnie takie typowe zarządzanie środowiskiem kontenerowym, takie jak właśnie podnoszenie wersji Kubernetesa, czy powoływanie nowych klastrów, czy jakieś audyty, role dla użytkowników i tak dalej. Rancher dostarcza taki pojedynczy punkt, gdzie możemy naszych użytkowników zautentykować i od razu przyznać im odpowiednie dostępy, mając ogląd na całe środowisko i właśnie w ten sposób utrzymując spójność naszych ustawień, spójność też polityk bezpieczeństwa, spójność też zasobów, w sensie zarządzania zasobami, kwotami i też dostajemy z Rancherem pewne usługi, jak to nazywamy usługi platformy, czyli dostajemy katalog aplikacji, dostajemy od razu do użycia gotowy serwis mesh, monitoring, storage kontenerowy Longhorn, więc dostajemy pewien zestaw już właśnie funkcji do zarządzania tymi kontenerami, żeby ogarnąć tę rozległość, tę złożoność, jednocześnie zachowując bardzo dużą elastyczność i bardzo dużą otwartość. Rancher jest takim bardzo podłączalnym rozwiązaniem, gdzie możemy podłączać bardzo wiele innych rozwiązań ze świata Kubernetes, takich jak pipeliny CI/CD, czy rejestry kontenerowe, czy inne rozwiązania, tak żeby stworzyć właśnie kompletne środowisko, a Rancher ze swojej strony gwarantuje, że to będzie poprawnie działało. Więc to tyle, jeśli chodzi o taki ogląd z lotu ptaka, czym jest Rancher, i myślę, że dużo lepsze wyobrażenie będziemy mieli o nim, jak po prostu sobie go obejrzymy. Więc go wypróbujmy. Tak jak wspominaliśmy na początku, wspominaliśmy użytkownikom, którzy są tu obecni na sali, ale dla Państwa, którzy są w internecie, czy gdzieś tam przed ekranami, to jest nowa informacja. Teraz jest ten moment, żeby przejść sobie w przeglądarce.
Jaroslav, before you begin, I think there's an error in the access code. The access code is Rodeo 1012.
1012. Oh.
maybe I can switch over to my screen.
Yeah, sure. We can do that. Yep. Just give us a second. Yeah, over to you, Jan.
Okay. Cool. Yeah, sorry for interrupting you. Did you want to say anything more, or should I make the introduction?
No, I was just about to explain, the code and everything. So okay. You can feel free to take over.
I'll take over. Okay. So, as Jaroslav said, if you would just just listening to someone telling you how great it is to use Rancher for Kubernetes, it's too boring. So what we want to do is today we actually want to try it out firsthand using our own lab environment. And what we have prepared to do that is what we call our hobby farm, which is basically a learning platform where every participant gets a number of virtual machines running Linux. And then we go together through some exercises, including the setup of Rancher and provisioning Kubernetes and Kubernetes workloads. So let me just quickly introduce you to the platform. I hope by now you have already opened the browser and went to the website, which is learn.eu hobbyfarm.io. In there, you have two tabs. One is login, one is register. So when you go there for the first time, you should go to the register tab and then enter your email, choose any password. And most importantly, you need to enter the correct access code. That's very important. And the access code is Rodeo 1012. Once you have entered that, you should directly go to a login form, and then you should be able to log in into the platform using your email and your password. In the case that you don't see any scenario, so you're seeing a screen like this one, then please check that you have entered the correct access code by going to the user menu and go to manage access codes, and there you can double check that you have in fact used the correct one. So one important note is you will get, so once you log in, Hobby Farm will provision you 2 virtual machines, and it will also start a user session for you. So whenever you step away from your computer, maybe to take a break or something, I recommend you to use the pause scenario button, which is the blue button here, to make sure that your session is on hold and that your virtual machines are waiting for you when you come back to your computer. Also, all the steps that we are doing now, I will talk you through them, but they are also documented in the dashboard in the learning platform. So if you are quicker than everyone else, feel free to go through the steps yourself. But I would ask you to stop at the step where it says accessing Rancher. So basically after the installation, let's stop there and then go over the rest together. Jaroslav, do we also plan to do a coffee break at some point?
Yeah. There's a coffee break in approximately 5 minutes.
Oh, okay. So yeah, then we will. Then we have to hurry up to get something going here. Okay, so let me pull out also my browser in the meantime, and walk you through the first steps in the platform. In the meantime, are there any questions, Jaroslav, maybe?
We have some questions on chat. Maybe we can help.
Yeah. I'll have a look at the questions and answer them. Okay. Tak, pierwszy krok to jest rejestracja. Ona może być jakimkolwiek adresem e-mail i jak już mamy zarejestrowani, jak jesteśmy zarejestrowani, jakkolwiek, z jakimkolwiek hasłem, się logujemy i potem podajemy to hasło właśnie Rodeo 1012. Tak.
Yeah, exactly. So let me just show you again. So the first thing I did was go to the register tab here, and then entering my email address, the access code, Rodeo 1012, and any password I would like. Then I hit the register button, and as soon as I've done that, I can then log in using that email address, the account that I just created. And once you have logged in, you should see a scenario on your screen, which is called Rancher Rodeo 14, 2.6. And when you see that, you can also click on Start Scenario right away to start the scenario. If you don't see that, then again, you can go to your user menu here on the right side, go to Manage Access Codes and double check that your access code is in fact this one, Rodeo 1012. If it's not, you can modify, you can delete it and add the correct access code again. And when you've done that, you should log out and log in again, and you should be able to see the scenario. So at this point, let's start the scenario. You can see that the virtual machines are actually now provisioned on demand. This may take anywhere from 30 seconds to maybe 3-4 minutes. Given that we are a lot of people today, including the people remotely, I'm really curious to see how fast it will be, because we are almost 200 people. So what we can also do actually, Jaroslav, maybe we can take the coffee break now, since we are waiting for the virtual machines anyways. What do you think about that?
Yeah, sure. Let me ask the audience. Okay, the audience agrees. So so let's call it a break until how long do you think? 10 minutes, 15?
Yeah, usually 10 minutes should be good.
10 minutes.
Should we call it 10 past 11? Should we call it?
Yeah.
Yeah, okay, 10 past 11.
Good.
Okay, w takim razie przerwa. O 11:10 równo zaczynamy z powrotem.
Hello, Jan.
Hello, Jaroslav.
There's a question that's come up in the chat. How long will the platform be available after the rodeo?
Yeah, so we will clean up the platform at 3 p.m. this afternoon.
Okay, so everyone
Until then, everyone still has access if they want to.
Okay, so 3 p.m. Excellent. Thank you.
Okay, so how is it looking on your end in the real world? Is everyone back at the place?
Mostly, yeah. Most people have come back.
Okay. So should we give it another minute, or should we start?
No, I think we're okay to go. Yeah, there appears to be over 190 people online. So there you go.
Okay, cool. So can you see my screen still?
Yep.
Okay, perfect. So yeah, so I hope everyone should by now have their VMs provisioned. If not, please let us know in the chat, in the questions. For me at least, it's working. So yeah, please give feedback. As you can see here, we have 2 virtual machines. They have been provisioned in the AWS cloud, running SLES, SUSE Linux Enterprise, and each machine has a public and a private AP. So at this point, I'll click on Begin Scenario, and I will start by explaining a bit how the platform works. It's pretty straightforward. So on the left side, we always have the documentation on the exercise that we are doing with some explanations, and also the commands for the command line, if there's any. And on the right side, you can see we have 2 web shells, one for the cluster 01 virtual machine, and we have another shell for the Rancher 01 machine. What are we going to use these machines for? So the Rancher 01, we will use that to install the Rancher management software, which itself runs on a small Kubernetes cluster. And then once we have done that, we will use the cluster 01 machine to actually run our provision our workload cluster from within Rancher. And again, if you're stepping away from the scenario, there should be a pause button. Well, the strange thing is I don't see the pause button anymore. I think they may have removed it. Yeah. Okay. So maybe it's not needed anymore. Anyway, so at this point we can start. So let's click on the next step. And the first thing that we have to do is we have to create a Kubernetes cluster to run the Rancher software itself. Rancher is a Kubernetes native application, right? So it's there for managing Kubernetes. So obviously, why not use also Kubernetes to run the management solution? Rancher can be installed in any Kubernetes cluster. So you can use any distribution of Kubernetes to run Rancher, or you can even go in the cloud and get an AKS or EKS cluster, a managed cluster. But for this purpose, we are going to use RKE2. RKE2 is a CNCF certified Kubernetes distribution. So it's basically an installer and a configuration framework for Kubernetes. The nice thing about RKE2 is that it's really easy to install. Basically, RKE2 is a single binary that you can execute on any Linux machine as a systemd service, and it will give you a Kubernetes cluster from a single node cluster to a multi-node cluster. In this case, we are just creating a single node cluster with a single virtual machine on the Rancher 01. And all we have to do is to run the installation script, which you can see here on the left side. So obviously, you don't need to copy paste the command. All you need to do is click on the box, like I'm doing now, and you can see it copies the command in the shell and then runs the installer. What this installation does basically is really just downloading the RKE binary and then creating a systemd unit file and activating that. So it's not activating it, but it creates a systemd unit file, and that's basically it. So we'll wait a little bit until that is finished, and then we will have a look at the configuration as well. Okay, so now the installation is completed. The next thing we have to do is create a configuration file for RKE2. So this is where we can make any changes to how the Kubernetes cluster should be installed. And you can see that this configuration file lives in the following path on etc rancher RKE2. So we can double check that it has been created. And really, we are using the default configuration, right? So we are not specifying a specific version of Kubernetes or doing any other changes. The default configuration is fine for our purposes. The only thing that we're changing is the permissions for the kubeconfig file. The kubeconfig file will be created automatically when we start RKE2. And this will give us admin level access to the Kubernetes cluster, so that we can then use the installation tools like Helm or kubectl to install Rancher in the cluster. The next thing we're doing is we will enable the systemd service, and we will also start the systemd unit right away. So this now in the background, it will basically bootstrap and start up all the different processes that are part of the Kubernetes cluster that Jaroslav explained in the beginning, such as the etcd server, the Kubernetes API server, the kubelet, and all these other processes that are part of the control plane in the Kubernetes cluster. Yeah, and obviously that's the same approach if you want to add any nodes to the cluster. If you want to really build a larger Kubernetes cluster, it's exactly the same process. The only difference is that you're picking one of the VMs to be your sort of seed node. And then when you run the installation script on other VMs or servers, you will point them to the seed node so that they form one cluster. Okay. So now we can check the startup logs by using the journalctl command. And it seems it's fairly stabilized. So that looks like it's fully up. So let's go to the next step. So the nice thing about the installation of Rancher is that we're really using the standard tools from the Kubernetes ecosystem. So Rancher itself is installed with Helm, which is the package manager for Kubernetes. And kubectl obviously is the standard command line interface for Kubernetes. So it makes sense that we are also using that and having a look at it. Now I'm canceling the log stream, and the next thing I will start the installation of kubectl. So what we can do is now we can check that it has been properly installed. And we can see we got the version 1.22.2, which is fine. The kubectl command line is always, I think, 2 or 3 versions backwards compatible with the version of the cluster. So the next thing is we kubectl, in order to access a Kubernetes cluster, kubectl requires a kubeconfig file. And this kubeconfig file is always expected in the user directory under .kube.config. Obviously, right now we don't have that yet. Our kubeconfig, what is nice that once we have installed RK2, it will automatically create a kubeconfig file for us. So you can have a look at this. It's under this path etc Rancher RK2 YAML. And if you look at it, you can see that this is exactly in the format of a kubeconfig file. It has the certificate information. It has the API endpoint for the Kubernetes API server, in this case, the local host, because we are on the same machine. And it also has credentials in the form of a client certificate, which gives us admin level privileges. So because kubectl looks in a different location for this file, all we do is basically create a soft link here to the location in which the command line expects this config. Oh, okay, already created, and we can double check that. Yeah, it's there. Okay, so now that we have done that, we should already be able to communicate with the cluster. One of the simplest commands that you can do is listing the nodes that are part of the cluster. So nodes in Kubernetes is any computing resource such as a virtual machine or a bare metal server. That's what typically is referred to as a node. And you can see here we have our Rancher 01 machine. The status is ready. You can also see the roles that have been assigned to this machine. So each node in a Kubernetes cluster is configured with 1 or multiple roles. And in this case, we have the control plane ECD master role attached to this machine. You can also see the Kubernetes version that we're running. Next thing that we can do is we can have a look at what is actually currently running in the cluster in terms of containers or workloads. For that, you can use the kubectl get pods command. And one thing to note is that all these the pods are namespace resources. So if you query the pods in a cluster without specifying a namespace, it will only show you the pods running in a default namespace. So in order to get all the pods in the cluster, there's a nice shortcut with -- all namespaces. You can make it even shorter by running this with a -A like this. It's the same effect. And here you can see now the workloads that are running currently in the cluster. And you can see all this is basically like system level services. Like for networking, we have a DNS server running here, core DNS. We have Nginx ingress server running to terminate traffic from outside the cluster. We have the API server running here, so it's all system level services. But the important thing is that the services are also in a running state. I don't know why my web shell is very narrow, but yeah, I think everything is good. So let's go to the next step. Now we need to install Helm. So for those that haven't used Helm, as I said, it's a package manager for Kubernetes applications. So it works very similar to apt-get, yum, or other Linux package managers. The important thing is that Helm packages only consist of deployment configuration. They do not contain the actual deployment artifacts. They do not contain the container images, for example. So Helm, again, is also a command line tool which we can easily install by just downloading it with curl. Then we can run Helm version -client to verify that has been installed in a path. And then we can also check whether Helm is able to talk to our Kubernetes cluster by listing the Helm charts that are currently installed. And you can see that this works. The reason this works is because Helm consumes the same configuration file as kubectl, the one that we symlinked under .kube config. So at this point, everything is set up from the Helm side. Jaroslav, are there maybe any questions in the meantime? Jaroslav, I don't hear you if you're talking. Okay.
Sorry, I was in the audience and talking.
Yeah, I was. Yeah, I was thinking like that. Yeah.
There's
any question coming up in the chat maybe?
No, not that. I mean, we answered all of them so far. So so you're good. You can carry on.
Okay. Okay. All right. So let's get it going. Okay. So Rancher exposes a web console, a browser console, and obviously also an API. And we want to secure these endpoints with SSL TLS. Because we don't want to bring our own certificate, right? It's too much work to now start creating certificates. We will just use a self-signed certificate, and the component that we use to manage the self-signed certificate is Cert Manager. So Cert Manager is an add-on for Kubernetes that can be used to manage different kinds of certificates, self-signed ones, Let's Encrypt ones, or it can even also sign certificates on the fly. And this is the solution that we're going to use for that. So what we have to do is, first of all, we have to install some custom resource definitions in the cluster. You can see we are using for this kubectl apply, and then we provide a URL to the actual file that contains the definitions. And kubectl will download that on the fly and install it in the cluster. Now the next step we have to do is we have to add the repository for the Cert Manager. So basically the vendor repository, we have to add that to Helm. Quite similar like we add a repository to the Linux package manager. So we do this with Helm repo add. Let me clear my screen. And the next thing we do is we use Helm to install the Cert Manager component. You can see we specify a specific version here, and we also specify a specific namespace to install it into. So just click here on Helm install. Okay, so now it tells us that the Cert Manager has been successfully deployed. Obviously, this does not mean that it is actually ready to to serve requests. So in order to verify whether Cert Manager is fully running, we can use the kubectl rollout command, which will basically give us an indication of whether all the containers are started and are up. So let's run this. And it already comes back with successfully rolled out. There's also another component that is installed as part of the Cert Manager, which is the Cert Manager webhook. This is a component that will intercept requests for certificates and validate them. So it's quite important that this is up before we do anything. So let's also check that. It also says deployment Cert Manager webhook successfully rolled out. Okay, with this, we can go to the next step, and we can now finally install Rancher itself. Like before with the cert manager, we start by adding the Rancher repository. And then we run the helm install command to install Rancher. Let's quickly review the configuration that we are using here. Again, we are installing Rancher in its own namespace to separate it nicely from other workloads in the cluster. We are then configuring one variable, which is called hostname, with a public DNS name pointing to our Rancher server. So this is basically just using this service here, slib.io, to create a valid DNS name pointing to the IP address of our Rancher virtual machine. Right? This saves us from having to create our own DNS records. So the next thing that we're doing is Rancher typically is installed high available. That means you're running multiple instances of Rancher. This doesn't make a lot of sense because right now we are only installing on a single virtual machine, so we are reducing the number of instances to 1. And we can also select a specific version of Rancher. In this case, we are using 2.6.1. Okay. Okay, so that's very quick. You can see it's already printing out a URL for the dashboard to access. Obviously, we will still have to check that it's, we still have to wait until it's actually up. Because, during the first installation, there's a lot of bootstrapping happening. So we can run this nice for loop or while loop, which basically will check whether Rancher is the Rancher UI or Rancher API is already fully up. So we can just click that. You can see it runs in a loop to check whether Rancher is available. Once this script finishes successfully, we can then go to the URL to continue setting up Rancher there. Maybe one question from Arthur is how Rancher, how do Rancher updates look like, and how do upgrades impact the managed instances of Kubernetes? So first of all, updates are working exactly in the same way like the installation. So we use Helm to manage the lifecycle of Rancher, and to do, and it allows Helm also allows us to do rolling upgrades, so that we can upgrade Rancher without considerable downtime. For the other question, how does it impact the managed Kubernetes clusters? It is important to understand the architecture approach of Rancher. So other than other Kubernetes management solutions, Rancher, the management component from Rancher does not run in the workload cluster itself. Instead, we are having a dedicated central management instance, and all we do for the workload clusters is to run an agent in the cluster that registers and connects the cluster to the central Rancher management server. That also means that there's a very small coupling between the two, and basically when Rancher is down, the clusters continue to work just fine. Everything that changes is that during the time of Rancher's down, you might not be able to make any changes, but the workloads in the clusters are still working fine. As we can see now, Rancher is ready, so we should be able to go to the next step and open the URL that is printed here, which will take us directly to the dashboard. So depending on what browser you're using, you may get a warning about certificate because we're using a self-signed certificate. I've not yet figured out what determines this, but sometimes you get a button where you can just continue and accept that you're using a self-signed certificate. But sometimes, like in my case now, there's no button actually. So what you have to do here, if you're using Chrome like me, you have to basically just put the mouse cursor anywhere here on the screen and then type on your keyboard, this is unsafe, without any spaces. This is unsafe. So maybe Jaroslav can also post that in the chat. And that way Chrome will then accept that you're using a self-signed certificate. Yeah. So again, you have to type this is unsafe. Yeah. If you have any problems with the certificate, please let us know in the chat. But anyway, so now we are up here, and you can see that for our Helm installation, we had a bootstrap password was created for us, which we have to fetch now using the kubectl command. So you can just click this to copy the kubectl command here. And then basically paste it here in the Rancher 01. And you can see the output is this line. This is the token. And we copy this. And when you copy this token back, you can then specify your own custom password for the local admin account. Okay, so now it will prompt you to set your own password for the default admin user. You must agree to the terms and conditions. And then you can, why is that not working here? That's weird. Does the password not fit? Ah, okay. Maybe the password did not fit or something. I don't want to collect any statistics, so I disable that. And then I can click continue to set the password. So I'll give everyone a minute to do these 2 steps of setting the password before I continue. Yeah, so I saw that there's one person who has a problem with the web shell, with the terminal, which is not showing. So make sure that you're not behind like a enterprise internet proxy. This could sometimes cause problems because the terminal uses WebSockets connection. Otherwise, try to maybe do a hard refresh of the browser, or maybe try to switch to Chrome or some other Chromium-based browser. Or also, if you're connected to a VPN to your company, maybe try to go out of the VPN. Okay, so now I will click continue. And now we can see we come to the main dashboard of the Rancher management server. Here you can see the list of, on the bottom side, you can see the list of clusters that are currently registered and managed by Rancher. In this case, it's the local cluster basically refers to the cluster that we have just installed. And you can see here on the left-hand side is the main menu, where you can access the different sections. You can go to inside a cluster to manage the configuration and workloads of a cluster. And you can set up things like continuous delivery, virtualization management, and cluster management. On this level, you can also access the global settings. So these are the Rancher server settings, basically. And you can also access the user authentication section. Typically, when you install Rancher, you will not use local users, but instead you will connect Rancher to some authentication provider and really not manage any local user accounts. But for testing, it's fine if you just make use of the local users. You can see you can actually create more user accounts if you want and assign permissions to them. The permissions in Rancher follow the concept of Kubernetes, meaning we follow the airbag privilege management, role-based access control. And the roles that are part of this airbag management are managed also centrally in Rancher. So you can see we have divided that in global roles, cluster roles, and project namespace roles. So each role, each scope pertains to specific privileges, right? So for example, on the global role, we can manage permissions, for example, to create new clusters. And on the cluster and the project scope, it's more about who can manage specific workloads and things like that. So the next thing, we want to have actually a Kubernetes cluster to run our user workloads. So for that, we navigate here to the global apps cluster management, which allows us to manage the lifecycle of Kubernetes clusters from the installation time to scaling up clusters to patching cluster versions, and all these things are managed here. So Rancher supports different processes on how actually creating new clusters. So the different approaches are visible once you click the create button here. Before we continue, make sure that you are setting this toggle here on the right. So it's now set on RKE1 by default, but we want to already to use RKE2, which is currently in a technical preview. RKE2 is basically the same distribution that we also used to install our Rancher cluster with the command line. So we want to use the same distribution also for our guest workload cluster. And here you can see there's different ways to create clusters. So with Rancher, you can provision a managed Kubernetes cluster directly in the cloud, or you can create a cluster on top of any virtual machine instances and compute instances in public and private cloud, like on vSphere. You can also create a cluster on existing infrastructure. So that means you already have some bare metal servers or virtual machines installed with the Linux operating system. And then you can involve Rancher just to install and manage the Kubernetes layers on top of that. So this is exactly what we are going to use, because we already have our virtual machine, the cluster 01 machine, and we want to use that to create a Kubernetes cluster, a single node Kubernetes cluster. So for that, we are now choosing this custom approach, sometimes also referred to as bring your own compute, because here Rancher is not involved in provisioning virtual machines. And then we can start by assigning a cluster name and choosing the Kubernetes version that we want to use. So in this case, we are choosing the version 1.21.5. You can see there's some basic configuration available here. Like, for example, you can select the container network provider. Every Kubernetes cluster has basically its own network layer as a sort of software-defined network. And depending on your use case and the infrastructure, you can select different solutions for that. If you want to later on customize your clusters with your own configuration, maybe implementing some hardening to improve the security and things like that, you can use the different configuration options available here, including, for example, setting up private container registry to provision the clusters. But for our purposes, we will basically leave everything at the default. So I will call this user cluster. And then I will just hit create button. Okay, so now our cluster is in provisioning state. The next thing we have to do is we have to register the servers, or in our case, the virtual machines that should be part of the cluster. You can see this registration. We are doing this by running a curl command on each of the existing virtual machines that we want to register in the cluster. And we can also adjust, for example, what role the virtual machine should have in the cluster. So should it be part of the control plane or should it be a dedicated worker node? In our case, because we have only a single virtual machine, we choose all the roles. And the other thing that we have to adjust is the IP address information. Because when we look back here on our terminal and go to cluster 01, we can see that we have two IP addresses because we are running in the AWS cloud. We have a private IP and a public IP, and we have to provide Rancher with the information about these IP addresses. So I'm already copying now the public IP address to copy this over. And then I'm clicking here on show advanced settings. Yeah, under the step 1. And you can see there's two fields here. One is called node public IP. This is where I'm copying the IP address, public IP address from cluster 01 machine. And the next field is called node private IP. And this is where I'm copying this private IP from here. Just make sure that you're actually on the cluster 01 terminal and not the Rancher 01 terminal. Make sure that you're using the correct IP address. You can also copy it from here, which has already populated this with the correct address. So that's the advanced settings. The next thing is we need to make sure that our agent accepts the self-signed certificate that we are using for Rancher in this lab. So make sure you check this box under the registration command under step 3 insecure, select this to skip TLS verification. So this is for our self-signed certificate. So and now what we can do now is basically just copy this command, the registration command, and then run it on any virtual machine or server that should be part of our new cluster. So with this, we can go to the next step of the scenario.
Jan, can I just interrupt you for a second?
Sure.
There's a few questions about the password to Rancher, because some people are unable to find the password. Maybe could you go back quickly to that and explain it maybe a little more?
So when you install Rancher, a bootstrap password is a random bootstrap password is generated. When you access the Rancher UI for the first time, you must enter this bootstrap password. So how do you get this password? You need to get it from the terminal, from the Rancher 01 machine, by running the command that is actually in the UI. So when you open the Rancher UI and you're not logged in yet, it will show you a kubectl command. I cannot show it now because I've already configured my own password, but it will show you a kubectl command, and just copy paste this command here. You can still see it here, right? So I copy pasted this command that the browser UI gave me. kubectl get secret, and then it prints out one line with a token. Then you copy this token and you paste it in the Rancher dashboard. And in the next step, you can then configure your own custom password. I hope this makes it clear.
Yep. Thank you.
Okay. Yeah. Thank you. Okay, so let's get back to the step. Okay, so now we are here at this step, cluster bootstrapping process. So what I have done now, I'm copying the registration command. And by the way, so for the participants that are still stuck in creating their password, I will make a short break in a minute, but you can basically just follow along the steps to pick up. Yeah. So what I'm doing now is I'm copying the registration command and then going to my cluster 01. So I'm making sure the terminal selected here. And then I'm just pasting this command. So you can see this is a curl command. This will install an agent in our on our virtual machine, and this will start to bootstrap the Kubernetes cluster on this virtual machine. When I go back to the Rancher dashboard, I can then open this other tab, which is called Machines. And you can see I have already one machine here that has registered. So Rancher is already aware of this machine, of our virtual machine. And it's now starting to provision. In my case, I am also interested in the log from the Rancher system agent. So I'm using the journal control to watch the logs. Should I run that with sudo? Yeah, it seems like it's doing its stuff. So let's have a look back. It's still in the provisioning phase. So let's just give it a little bit time, and it should just take off to bootstrap all the Kubernetes components. Okay, so at this point, maybe some feedback from the other users. So for me, the machine is basically up now. You can see the virtual machine is in a running state, and the cluster itself is also active. So basically, I'm ready to use this cluster. It took around maybe 4 minutes to set this up, so still pretty quick. Maybe have a look what we can do from here. So you can see in this view, it shows me all my virtual machines that are part of the cluster. I can check the configuration of the machine. I can also make some changes to it. A lot of things are still in YAML file here because it's basically impossible to make a user interface for everything in Kubernetes. But that's also just for advanced things. What we can also do from here is to check the configuration of the cluster itself that we've used to install it. And we can also do things like taking snapshots of the cluster, restoring a snapshot. And we can actually also access the cluster directly from here using a kubectl shell. So when you click on this context menu, run kubectl shell, you get a terminal where you can run Kubernetes commands directly on the machine, like we did before. You can do this directly here, or alternatively, you can also download a kubeconfig file. And with that file, you can then use the cluster from your own workspace, from your own console, to do everything directly on the command line. Also some explanation on how to manage lifecycle of the cluster here. So for example, let's close this. For example, let's say you want to patch the Kubernetes version of the cluster. This is all done by editing the configuration file. So we are already using the latest version available here, but as soon as there are new versions of Kubernetes available, Rancher will update this for you, and you will then be able to pick the new version and to apply this to the cluster. Jaroslav, what is your impression? Can we continue, or should we still give some time?
Hold on a second.
There's one question maybe about the cluster.
Robimy przerwę, czy jedziemy dalej? I think we're okay to carry on.
Okay, let me just quickly answer a question from Jaroslav. So how did we create this cluster? So basically, you go here to the global menu, to cluster management. Then you click on create cluster. Make sure that you are using RKE2 as an option. And then we choose the custom one. Provide a name here. So I can obviously create another one here. Click on create, and then it shows you the registration command that you need to run. And here again, make sure that you configure the public and private IP address and select insecure for the registration command. And then you can just copy this whole curl command and then execute it in the terminal for the cluster 01. That's how we create the cluster. And that's where we are at this point. Let me clean up this one because we're not using it. Okay. So let's see what we can do with our newly created cluster. So first of all, let's explore our cluster. So here in the list, you can select, you can go to the cluster minus called user cluster, and then on the right hand side, there's a button with explore. So let's open this. And basically what we see now is a view inside this specific Kubernetes cluster, starting with a global dashboard that shows us the available capacity, the available compute resources like CPU and memory in the cluster. We get a stream of all the events happening in the cluster. And on the left-hand side, we can explore all the different resources in the cluster, from the containers and deployments that are running there to things like persistent volume storage and everything else. So all the resources in the cluster can be managed from here. And you can, for example, go to deployments, and you see all the deployments that are currently running in the cluster. And if you want to, for example, troubleshoot something, maybe one of your deployments is not working correctly, you can use that to actually dive down to all the lower level entities of this deployment, like for example, to the pod level, right? So here it now shows you the pods that are running as part of this deployment, and I can now interact with these pods exactly like on a command, like for example with Docker command line, by opening a terminal in the container, or for example by viewing the logs of the pod. So it's an alternative to basically using the command line to have this user interface to make managing the cluster resources more efficient and more easy. Yeah, and as I said before, you can also open a kubectl shell from here, which we already did, and you can also download the kubeconfig, which you can then use to run the kubectl command line from your own local shell. So one thing to note about Kubernetes is that, let's go back. Interesting. Let's go back to the dashboard. So one thing with Kubernetes is not tracking the actual load on your cluster in terms of what are the actual resources that are currently used. Kubernetes uses a reservation system to manage the resources in a cluster. So reservation is not actual usage. So if you want to have a better way of understanding how your cluster is currently working, like for example, are you at 100% usage, for example, or do you have problems maybe with available disk storage or something like that? You need to enable some additional monitoring solution in the cluster. Rancher makes that very easy because we ship a monitoring solution consisting of Prometheus and Grafana, which you can easily enable. So let's see how we can do that in this cluster. So all the add-ons that are available for installation in a cluster, you can find them under the apps and marketplace. So when you open this apps and marketplace, let me zoom in a little bit. You get here installed apps, repositories, and charts. Repositories basically allow you to add also your own custom application here based on Helm charts and Helm repositories. So you can see we have some default charts with partner solutions and with our own charts. And once you have registered a repository, you can then browse the available applications here. And in our case, we want to enable them. We want to use the monitoring stack. So let me just search for monitoring here. And this is the thing that we want to use. This will provide us with a full-fledged monitoring solution based on Prometheus Grafana, including possibility to set up alerting and things like that. So let's click on that. And yeah, here you can find some information about this chart, what version it is, some release notes and things like that. But we really want to do is install it. One thing to note is that obviously this monitoring also requires some resources. In this case, for example, it requires around 4 CPUs, but it notices that our cluster only has 2.7 CPUs available because we're running on a relatively small single virtual machine. So we have to actually change some configuration to make it work either ways. In any case, let's click the install button. And this sort of starts a deployment wizard. In the first step, we can add some metadata, but we will just skip that. And then in the next step, you can see here, we have to change the resource limits and lower the amount of CPU and memory requests for the application. So this just ensures that we can actually run it on the cluster. So let's click next here again. And now we are on the install step 2, and we can now adjust our deployment. In the left side, click on the Prometheus tab. And you can see here, there's one option called requested CPU. We will make this a little bit smaller and change this to 250. The M, unit M, stands for milli CPU. So basically we are requesting here a quarter of a CPU. And the same thing, we do that for the memory. So by default, it requests 750 megabytes, and we will reduce that to 250. Yeah. The limits we will not change because you can over provision. So that's not a problem if the limits are higher than what we have. Yeah, once we have changed that, we can then click install. And then this will start to install all the components that are part of this monitoring stack into our cluster. And once the installation is completed, so you can follow along here in the log, once this is completed, the user interface will actually reflect that by providing us a new menu option to access the monitoring. Yeah, you can see these charts are sometimes quite big, and they configure a lot of different resources, and that's why it also takes a little bit of time to make this installation. There's one question about a limit of 110 pods. I think this is, where does this pop up? I think this is visible on the dashboard, I think. Yeah, exactly. You can see, so there's one capacity expressed in the number of pods. And because we have a single virtual machine, that capacity is 110. Yeah, this is basically a default limit that Kubernetes configures. I think it's just basically based on average density of pods per server. And it's also probably based on that, on the scalability of the container runtime on a server, especially maybe in the times of Docker, where maybe you could not use a single Docker to run, 300 containers. So that's kind of a value that is just based on experience. But if for any reason you want to run more than 110 pods on one server, you can change this limit. But I would say, like, average clusters, they have anywhere between 20 to maybe 80 pods per server, depending on the size and of the servers and the workloads. Okay, so let's go back to our menu here. And you can see now we have a new tab here called monitoring. And this allows us to both access our monitoring, but also to configure it. Because this monitoring stack allows us to, for example, set up alerting rules and receivers. Like, for example, here, I can set up a receiver. A receiver is basically an output for an alert. And for example, if I set up an alert based on some condition, like, for example, my node is going offline, I can then trigger an alert and send it to some of the outputs I configure here. The monitors allow me to define the monitoring targets. So because I have some default monitors, as we can see here. So that means, so these are all the components that are already monitored as soon as I install the monitoring. So for example, the etcd server is monitored, or the kubeproxy is monitored. But obviously, in addition to that, I can also use that to monitor my own applications, for example. And this is where I can set this up. Oh yeah, we can also have a look at in the app and marketplace. Now, when we go back to installed apps, it will show us our Rancher monitoring stack that has been deployed. You can actually see that this has deployed over 200 different Kubernetes objects. And if there's any update to the Rancher monitoring stack, this is also where we can actually upgrade the version if we want to. So let's go to the next step, which is called working with Rancher monitoring. So when you click on the monitoring menu, you get basically an overview of the components that have been installed. And one of the components that is important or is valuable for us is Grafana. So when you click on the Grafana component, it opens a new tab with a Grafana dashboard. You can see that this service is actually provided on the Rancher endpoint, which also means that it's basically access controlled by a Rancher. So I can only access that because I have the permissions to do so. In Grafana, we can see when you click here on the dashboard home, maybe on the manage. When you click on manage, you can see there's a number of default dashboards already provided. So these are sort of like the best practice dashboards, right? For example, if you want to understand how your cluster DNS is performing, you have this dashboard to see the response time of the DNS resolution and things like that. And a number of other dashboards are already provided here, but obviously you can also create completely your own dashboards based on the available metric. And you could also use this to create application level dashboards, like for application performance monitoring and things like that. Prometheus is a time series database. You can use this user interface to make queries in the data that is ingested in the database. This is useful if you want to create your own dashboards and you need to find out how to query specific data and how to roll up data and stuff like that. So that's kind of the monitoring stack. Will not spend too much time on that. So the next thing, we want to figure out how to actually get some workloads running in our cluster. So because we have this user interface, we really do not need to have a lot of expert knowledge on Kubernetes. Basically, if we have a container image and we know how to expose it and on which port the service runs in the container, we are able to deploy this with Rancher. So as an example, we have a demo application which is called Rancher/Hello World. But you can obviously use your own container image if you have one for this step. And this really just goes to show, like, how can we, starting with a container image and not having to write any Kubernetes YAML files, how can we still deploy and manage our application? So for this, we go here to the workload menu in the Cluster Explorer. We select the deployments. And deployments, I think Jaroslav already explained that, is basically an abstraction in Kubernetes to deploy and manage the lifecycle of an application in an easy way, because typically you're not working with pods or containers directly, because that would be too much work actually. So in this case, we create a new deployment by clicking on the create button. And then all we have to do is, obviously we have to decide on a name for the deployment. So let's see, let's call this Hello World. You can see we can also at this time already deploy an application that runs with multiple instances for high availability. But for the time being, I think we leave this, oh no, we can already bump this up to 2 replicas. So replicas means the number of container or pod instances that should be run as part of the application. The next important thing that we need to configure is the container image from which this application runs. So we will just use this Rancher Hello World one. And then obviously, because we are deploying a web application, we also want to access this application once we have deployed it. So we know that this one is, this container image is running on port 80. So what we're going to do is we're going to set up the port here under ports, click on add ports. Then we will select as a service type the type node port. What this service type does is basically it will assign a random port on the external host interface of our servers, so that any request that is sent to that port will be forwarded to the Rancher Hello World application and then processed and answered there. So let's select service type node port, and let's just call this HTTP. And under private container port, we configure the port 80. And the listening port, we will leave this empty because we want we don't want to manage, port allocation. Kubernetes should make sure that this port is not in use for us. Yeah, obviously, if you look here on the left-hand tab, there's a lot of different tabs that you can still use, because obviously this should not be like Kubernetes Lite. I mean, it's a user interface. It saves you from writing YAML, but you should still have all the options that Kubernetes gives you for scheduling, like configuring networking, configuring health checks and stuff like that. All that is obviously available, and if you have some time on your own here, you can explore the different options that are available. Okay, so for us, this is all that we want to configure now, and we click on create. And basically, what Rancher is doing now, it will translate our input into native Kubernetes configuration, and deploy this application into our user cluster. And the Rancher user interface gives you always a live view into the connected clusters that are managed here. That's also important to understand. So when we make a change here, Rancher will immediately apply this change to the user cluster. And the same thing if there's a change in the cluster, like for example, a pod is being stopped, then we will see this change also directly here in Rancher. So now we can see there's a Hello World application. We can sort of click on it and see that there's 2 pods running exactly how we wanted to. And when we go back 1 level up, it will also show us how to access our application. Here on the right-hand side, you can see there's a high port allocated, and you should be able to click this port and see the demo application. Yeah, so this application is kind of nice because it shows you from which pod this request was answered. So I think this should translate to the pod name. You can just compare this. Suffix KS NS9. Yeah, okay. So that's kind of nice because once you set up like load balancing for this application, you will actually see that you get a load balancing effect when you refresh the page. Okay, so that's basically all we have to do to deploy a very simple application in our cluster. Obviously, what we did now is we did not only create a deployment, but because we set up a pod, Rancher also created a service for us. And when we navigate to the left-hand menu, Service Discovery, and open Services, and then filter for Hello World, you can see the service here. Yeah, so we have here the service Hello World Node Port. This service makes it so that we can send requests to this port on the public IP address of our virtual machine, and it will be forwarded to the Hello World application. So obviously, using some random port is maybe not the best way of exposing an application. So that's why in Kubernetes we have an alternative way of publishing an application outside of the cluster, which is called ingress. And in ingress, the ingress in Rancher RKE2, what is actually the solution providing the ingress? Because an ingress typically is a reverse proxy. And in Rancher RKE2, that reverse proxy mechanism is provided by Nginx. So it's a well-known solution, obviously. But what is nice about Kubernetes ingress is we do not need to program our Nginx by writing some specific configuration files and reloading the server every time we make a change. Instead, we use an abstraction, which is called an ingress resource. And then Kubernetes will take that abstraction and manage the Nginx configuration for us. So to try this out, let's follow the next step. So let's go to Service Discovery and Ingresses and click on Create. And what an ingress really is it allows us to define routing, a layer 7 routing for HTTP requests that are sent to port 80 and 443 of our cluster machines. So any request sent to port 80 or 443 will be processed according to the rules that we define here. And now we want to define a rule to route requests to our internal Hello World application based on the host name. So what we do for this is we, first of all, assign a name to our ingress. And then we need to come up with a unique host name for our application. Right? So this could be something like an internal domain name, and then maybe the cluster name, and then the application name as another label. In our case, we make use again from this service slib.io, which will return our public IP address for this name. So we enter this under request host. For the path, we choose the root. And next, we have to select a target service. So this is basically the backend to which the ingress router will route the request that matches this host name. And here we select the Hello World node port. as a target service, and under port, we select the port 80. And that's all. Now we can click create. And now the Nginx ingress will be now reprogrammed to apply this routing. And then we should be able to access the application on a standard port 80 using this DNS name. And now that we're using Ingress, we actually also have load balancing in place. And by default, it uses a round-robin load balancing by forwarding the requests across and sharing them, distributing them across all the pods for our target application. So again, if we go back to our application under the deployments and go to the Hello World application, we can see that currently we are running on 2 pods. We can actually also scale this up. For example, go to the context menu in the deployment, go to edit config, and change the number of replicas to 4, for example, and then click save. Now you can see Hello World has been updated, and now we are running 4 pods. And if you now go back to your ingress and you refresh, you can see that every request is processed and served by one different pod instance. And that gives us a very easy way to scale up any application by just any stateless application, but just creating additional pods so that the requests are distributed across the pods. Okay, any questions in the meantime, Jaroslav? There's one question, maybe I read this myself, from Arthur. Where is the load balancer deployed? On RKE, where Rancher is deployed? No, it's not running on RKE. The load balancer is deployed on the user cluster as a workload there. So again, this is done with the intention of having a low coupling between Rancher and the cluster, and so that when, for example, there's a communication outage, a network outage between Rancher and your cluster, your application is still working. So basically, if you look at the nodes in your cluster, the Nginx ingress is running on every node here, and you can basically send your client traffic to any of the nodes. Or maybe you have some layer 3 load balancer in front, and you can then send the traffic to any of the nodes and it will be processed. There's also another question from Victor. Can any other port besides 80 be used for ingress programming? Yeah, you can customize that. I think you can even do that during the cluster configuration. So when you deploy the cluster, you can configure a different port. Okay. So we have now seen how we can easily expose an application on a DNS name for clients that are not in part of the cluster. The next thing is we want to look at projects and namespaces. So the project namespaces, the main purpose of using projects and namespaces in a cluster is really to have shared clusters, to have multi-tenant clusters where you have different applications, different users, different user groups sharing the same resources of a cluster, but at the same time having a level of isolation between their resources. And that is exactly what projects and namespaces allow us. They allow us to separate tenants and resources in the cluster. So let's navigate to our cluster, and let's go to project namespaces. And now it shows you the existing projects, and there's just 2 of them. So these projects are always created by default. The default project is always empty. You can use that to deploy your own workloads if you want. The system project is the project where we manage all the system level services like the DNS service and things like that. Basically everything that a normal user should not touch. Only the cluster admin should have access to this. And now let's imagine that we have a new user group who wants to use our cluster. So what is the best way of onboarding this user to the cluster without interrupting any existing users is to create a new project for this user. So let's create a new project. And let's use the name that is given here, stateless WordPress. You can see now as part of the project, you can always define the members. So these are the users or user groups that have access to the project and its resources. The other thing you can do is you can also define quotas for the resources that this project may consume in a cluster. Like, for example, how much storage, how much memory can the project use? For our purpose, we'll just give the name, leave everything at the default, and click create. So now we have created a new project in the cluster that we can use to manage an application separately from everything else in the cluster. A project is really a collection of 1 or more Kubernetes namespaces. And all the namespaces that you create within a project then share the same configuration in terms of permissions or, for example, network policies and things like that. That is how you need to understand project. So now the project is empty. Let's create a namespace to actually deploy some application. So let's also call this stateless WordPress, the namespace. And you can see here, we could also now set some quotas and default limits for the namespace, but we'll just click create. So now we have a project stateless WordPress with a namespace stateless WordPress, and this is now our scope for our next deployment that we are doing for our next application deployment. So let's click to the next step. And now what we're going to do is we are going to make use of the apps and marketplace to make available a new application for deployment. So for this, you need to navigate to the apps and marketplace in the left-hand menu, go to chart repositories, click on create, and then add the following catalog. So just copy the URL here, https Rancher GitHub IO Rodeo. And now here I go to apps and marketplace. I select repositories and click on create on the right hand. So I call this Rodeo. For the target, this is an this is a Helm chart repository. Otherwise, I could also choose a Git repository as a target. Then here in the URL, I paste the URL that I copied from above. And then I just click create. Once I do that, Rancher will basically fetch the contents of the repository and make it available for me so I can deploy the application that are part of the repository. So I can now go to apps and marketplace charts. And I should be able to find the application from the repository. When we go to the next step, specifically the application that we are looking for is the WordPress app. So let's filter for WordPress and select the WordPress application. And let's start the installation wizard by clicking on install. So here now we have to select a target namespace for our application, and we are using the one that we previously configured, which is the stateless WordPress namespace. We can also select a name for the Helm chart release, Helm chart deployment, something like WordPress, for example, and then click next. What we can do now is we can actually change the WordPress and database settings. So the one thing that you could do is specify, for example, a WordPress admin password. If you don't specify one, it will be auto-generated. And then go to the last tab, which is called Services and Load Balancing. And that's, it says expose application using layer 7 load balancer. And copy paste the host name that is suggested on the hobby farm here. So it's WordPress dot and then the IP address .slab.io. So I will copy paste that. This is the host name under which the WordPress should be made available. And then you can just click install. So again, no need to adopt anything. You can set the WordPress password here under WordPress settings, and then just make sure that you are configuring the correct host name. Let's click install. So this we have already seen. Now the Helm chart is being deployed. And we can close this log. And on the left-hand side, let's navigate service discovery, ingress. And after some time, you should have a new entry here for the WordPress with the WordPress host name. So we can see if that's already running. Okay, so WordPress is not up, probably still populating the database. Obviously, we have a very good visibility in what's going on. So what we can do is we can go to workloads, click deployments. Now we can filter here by our project, or even by the project namespace that we created. And now it will only show us the resources that are part of this namespace. We can click on the WordPress deployment. And maybe we want to have a quick look at the logs of this pod. So we can go to the context menu, click logs. And we can see that there's an Apache process started. And it also says that the WordPress setup is finished, so it should basically work right now. So let's go back to our WordPress installation. Yeah, and we can see now the WordPress is up. Next, let's open the admin backend of WordPress. So you can do this by adding the path wp -admin. Which brings you to the admin backend, and then the username for the admin is just user, unless you change that during the configuration. And then you can provide the password that you created. Okay. You obviously have to remember it correctly. If you don't remember the password, you can find the password actually in a secret that was created. So again, here when you go to storage secrets, you can see there's a WordPress secret. And because we have here admin privileges, we should be able to actually see the password. Yeah, and copy it from here and use it to log in. So again, this was here on the storage menu, and secrets. This is where you find this WordPress secret. Let's see if there's some questions. There's one question about the projects. So resources can be assigned to projects, but not to users. Is there a plan to allow assigning resources to users groups, which they can later spend to create a new Kubernetes cluster? Yeah, so currently that's exactly right. The resources are tied to projects, and the user can use that many resources, as the project in which he is authorized to work. So currently, we cannot track it per user, but obviously you have a way to control it by assigning users to a particular project. And if you want to assign resources to just one particular user, then obviously what you can do is, for now, is create a dedicated project for this user. I don't know if there's any plans to change that, but it sounds like an interesting idea. There's also a question about how Rancher integrates with Google Cloud Platform infrastructure. There's 2 points on how you could integrate that. Obviously by registering, by running clusters on GCP and managing them via Rancher. And one way is to use cloud compute instances and then run your own Kubernetes on top of that using RK2. And the second way is to basically provision, like here, a hosted Kubernetes cluster via Rancher in Google, and then manage the cluster lifecycle and all the resources of the cluster in Rancher. Obviously, once you run a cluster like this in Google GKE, you can also then make use of things like adding storage from Google Cloud Platform to the cluster and things like that. At this point, let's go back to our WordPress application and just create a quick example post. Let's call this just here. Let's see what I remember from my Polish. Let's publish this. And where do I access it? And it's exited. So now we have our first blog post. And now we can obviously make a nice experiment, which will make it very visual. How is the relationship between a persistent application, such as a database, and a Kubernetes pod? So what we can do now is we can navigate back to our cluster and to the workloads. Go to deployment. Click on the deployment. Oh, sorry, wrong deployment. We have to navigate to stateful sets, because this is where we have our MySQL database. Then you can click on stateful set, where it shows you the pods. And now basically you can maybe simulate, infrastructure outage or something like that, or any other problem. We can simulate that by deleting the pod with the right-hand menu. And you can see the pod is deleted. And what Kubernetes does immediately is creating a new pod, because it knows that we want to have a database. So right away it creates a new pod. That's helpful, right? But what happened to our block? So obviously, until the database is fully up, you will probably get an error back. Yeah, because WordPress cannot yet establish connection to the database. But this should change as soon as the database is up again. So it's not, so now you can see now the database container is back up. So now when we refresh this, we don't get an error, but basically we get a empty WordPress, because we basically lost our persistent data. We lost our database. So that brings us to the topic of how do we actually deploy and manage persistent workloads in a Kubernetes cluster with persistent storage. And we want to actually try this also out, because it's an interesting topic, right? So generally, how does Kubernetes address this problem of writing persistent data in the pod? Because the default behavior is anything that you write in the file system of a container, it gets lost when this container is stopped or deleted. So how does Kubernetes address this? Kubernetes addresses this with the concept of persistent volumes. So persistent volumes is something that is managed separately from the pod as a separate entity. And it allows you to define basically storage to write persistent data to, and to attach that to pods. And the persistent volume, because it's maintained separately from the pod, it has its own life cycle. And that means, in our case, if we would have had a persistent volumes for our database, then once the pod was recreated, the persistent volumes would be reattached to the pod, and we would have maintained our database connection. So Kubernetes basically does not provide a storage solution. It provides only a framework or an interface. So we still need some kind of storage solution to actually provide the capacity to store our database. Obviously, typically this might be something like a cloud storage when you run in the cloud, or maybe an enterprise storage like a HPE or NetApp when you run on-premise, or a solution such as Rancher Longhorn as a hyperconverged storage solution. To make this, obviously we don't want to deploy something like this, and we don't have this in our lab. So as an easy exercise, what we can do is we can create an NFS server in our cluster that provides storage for our persistent application. So we do this with the next step, which is deploy the NFS server provisioner. And we can very easily do this by going again to the apps in Marketplace, install the NFS server provisioner app from there. And that's basically all we have to do. So let's go to the app in Marketplace, go to charts. And let's search for NFS server provisioner, which is this one. And start the wizard by choosing install. Because this is kind of like a system or a cluster level component. Let's install this in the kube system namespace. Make sure you choose kube system here. And let's call this NFS server. Yeah, we don't really have to set any options here. Yeah, so this will basically now run an NFS server, and it will also run a provisioner, because Kubernetes provides a framework for dynamically creating the underlying storage that is required for a volume. That means you do not have to pre-create something like, for example, a iSCSI LAN or something. Potentially, Kubernetes can automate that step for you. And this is done based on something called a storage class. So when you open the storage submenu, you should see an entry called storage classes. And there, our NFS installation has already created one. So what does this storage class mean? What does it allow us to do? It allows us to deploy an application requesting a certain amount of storage, persistent storage for that application. And we don't have to take care of anything else. Anything else like provisioning the storage, allocating the storage quota, and all these things is done by the provisioner automatically. So that's what the storage class allows us to do. So now we can basically go back and redeploy our application with this storage class, and then we will no longer have the problem of losing any data. So for that, let's go back to project namespaces and create a new project called stateful WordPress. Also, let's create a namespace in that new project. And let's go back to apps and marketplace, to the charts. Let's search for our WordPress chart. Start the installation wizard. We select the stateful WordPress namespace. Call it WordPress. So now we have to make one change here under the database settings. So you can see that it gives us an option to enable a persistent volume. And that means when we enable this option, that when we deploy WordPress, it will request a persistent volume of the specified size. And this volume will then be mounted or attached to our pod, so that any MySQL data will be written in a persistent volume. So we can also select our NFS storage class here. And that's all we have to change. Obviously, like during the previous installation, we want to set again the host name. So this time we call it like this. I'm also setting the WordPress password again. And now I'll have it installed. So what we can do now is to check whether the volume provisioning works, because you remember we did not create a volume beforehand. So now when we go to storage, persistent volume claims, we can see the claim, which is basically a claim is basically a request for a volume of a certain size. And we can see the status is bound. That means the request was already satisfied and a volume was created. And here's the volume. We can also see that is that this volume was created as read write once, which means it can only be attached to a single pod at any time, and that the storage class is NFS. So basically now we can start, maintaining our WordPress database, and in any case, like losing our database pod, Kubernetes takes care of recreating the pod, but it will also take care of reattaching the persistent volume, so it's not lost. So the next step, which we are probably not really able to do because we are already running the latest version, but one thing about Kubernetes, if you go back to the cluster management on the global apps, one thing to note about Kubernetes is that it is a project that is seeing rapid development, and it has very considerable short release cycles. So there's a new Kubernetes version every 3 months. And each version of Kubernetes is also only supported for up to a year. So having your Kubernetes clusters patched, is quite important. And you want to have an easy way to do that. You don't want to spend a week to patch your Kubernetes clusters. You want to have it automated and you want to have it reliable. And this is, I think, something where Rancher provides also a lot of value. So how do you patch Kubernetes? So let's say there's a new patch version available, like 1.21.6 or something. It will automatically appear here. You don't have to do anything. So Rancher will fetch this version. And then once that version is available, you can then just go to edit config, select the new Kubernetes version, and then click save. So that's basically all. Unfortunately, we were not able to test this now, but this is basically the process of upgrading a Kubernetes version in the cluster. You can see here, there's something about upgrade strategy. This actually allows you to influence the process in which the cluster is upgraded, so that you can configure it in a way where you can hopefully do that without any downtime for your applications. Yeah, and this brings us to the end of our lab exercises. At this point, I would sort of give the ball back to you, Jaroslav. I don't know how much time you have left to maybe also discuss some questions.
Yeah, thanks, Jan. Excellent demo, and thanks for handling that. We do have quite a few questions. So, do you think it might be a good idea to go through them now and try to answer?
Yeah.
So there's one person asking about integrations, network integrations with VMware NSX. Can you comment on that, please?
Yeah, so generally, Rancher supports any network integration that uses the standard interfaces that are available in Kubernetes. For the networking, this would be the container network interface, CNI. So any CNI plugin can be used. And NSXT also provides a CNI plugin for Kubernetes, so that can be integrated that way with the Rancher. One thing to note is when you create a cluster, right, we give you, maybe not this one, we give you some options about the networking. So these are the CNI plugins that Rancher will install and manage for you. If you want to use a third-party plugin like NSXT, you can basically tell Rancher not to deploy one of these, but deploy the cluster without a plugin initially, and then install the CNI plugin once the cluster has been created.
Excellent. Makes sense, Jan. Thank you. Right, and another question, well, the next one deals with the actually with the deprecation of Docker shim. So there's the person asking is concerned about the little activity on Mirantis's GitHub, and they are asking basically what's our position on using Docker D and Docker shim.
Yeah, so as you can see here, right now the default Kubernetes distribution when you create a cluster in Rancher 2.6 is RKE1. Right, and today we used RKE2 because it's the newer stuff, is more fun. But RKE1 is still the default, and this RKE distribution is using Docker as the container runtime. So it integrates only with Docker, whereas our new distribution does not rely on Docker anymore. It uses containerd as the runtime. So what does it mean if you have today RKE cluster? You basically don't have to worry because we will support RKE with Docker even once the direct Docker support in Kubernetes is removed. Basically by adding the bridge component or the plumbing into RKE. So you don't really have to worry about it. If you're starting now to create new clusters, at some point probably I would start to do them with RKE2 right away because it uses containerd, it's more lightweight. You don't have to worry about patching Docker and what is the future of Docker and things like that. So yeah, that would be my answer.
Yeah, excellent. Thank you. The next question is about clouds. How Rancher integrates with GCP, for example.
Already addressed that quickly. Yeah, so you can integrate it with managed Kubernetes clusters, GKE on GCP, or you can run RKE or RKE2 on compute instances in Google.
Yeah, sure. I think it's worth adding also that Rancher can make use of the integrated cloud-native mechanisms such as pod autoscaling and more nodes autoscaling, right? I think, but yeah, let us move on to the next one. There's few questions about NFS. Can we use more than one replica for NFS server deployment?
Okay, so one thing to point out about this NFS server, this is not really something that I would use or recommend for production. You can obviously use NFS storage, but typically then the NFS server you would not run this as a container in the cluster. But you would have like a dedicated NFS storage server outside of the cluster. Generally, when you consume NFS storage, you can configure that as shared storage, so that you can have any amount of pods accessing the same volume. We did not do that for WordPress because a database is not really suited for shared access to the database files. But if you have some other use cases, you can obviously use a shared access. Yeah.
Okay, excellent. There's a related question. How does NFS provisioner know from where to take volume meaning from which physical storage?
Well, the NFS provisioner in our case that we used, it stores the data on the local disk of the virtual machine where it's running on. But typically, as I said, you would rather connect to an external NFS server. So basically, you would configure an NFS share, and then the NFS provisioner would create volumes on that NFS share, basically by creating a new directory for each Kubernetes volume.
Right. Excellent. So there is a bit of discussion, well, actually a question. So resources can be assigned to projects, but not to users. Is there a plan for Rancher to allow assigning resources to users or groups, which they can later spend to create new Kubernetes clusters?
Yeah, this was already discussed. I think we can skip this. I already addressed that question.
Yeah, okay. I mean, this, okay, fair enough.
Maybe a question about downgrade Kubernetes version.
Yeah, that was an interesting one.
Yeah. So yeah, you can do that. What is important is you should not just downgrade the Kubernetes version, but you should always combine this with a snapshot to restore also the state of the etcd data from the previous version. And this is something that Rancher allows you to do. So it allows you to create snapshots for your clusters and then do a restore to a previous version. I have not yet tried it with RKE2, whether it allows you to also revert. But with RKE, it's with RKE that is working, and I think it will eventually also work with RKE2. Yeah.
Right. Okay. I think we are kind of running out of time here, and I still wanted to show just literally 3 slides to everyone. So I think we'll, if that's okay with you, Jan, we'll
absolutely
finish on that. And okay, so let me share my screen again. Okay. Okay. To przejdę na polski teraz, żeby zapowiedzieć jeszcze kilka rzeczy. Mianowicie tak, jest dostępne nagranie z naszego meetupu online prezentującego nową wersję Ranchera 2.6. Zachęcam do obejrzenia. Jeśli nie braliście udziału, dowiecie się trochę więcej o nowych możliwościach Ranchera. Zachęcam też do odwiedzenia naszej strony Rancher.com Events i jest tam zawsze aktualna lista wydarzeń, gdzie można albo nas spotkać, albo też się więcej dowiedzieć. Obecnie KubeCon w północnej Ameryce trwa. Na pewno niedługo też będą jakieś wydarzenia bliżej tutaj nas. I wreszcie zachęcam do przyłączenia się do SUSE i Rancher Community. Jest to taki nasz hub, gdzie można się dowiedzieć, czy to dowiedzieć więcej o produktach, czy zadawać pytania, czy po prostu podyskutować. Zachęcam również do przyłączenia się do Slacka naszego, też tam jest to sposób, żeby uzyskać wsparcie, czy właśnie troszkę się skomunikować też z innymi. I co? Myślę, że na tym będziemy kończyć naszą część online. Chcę tutaj podziękować jeszcze raz Janowi. Jan, thank you so much for joining. This was excellent demo and excellent workshop.
Thank you. My pleasure. It was great to have this webinar and also to have, unfortunately, I did not meet the people on premise, but also great to have so many people joining online. So that's great.
Yeah. Yeah, thanks again. You just got a round of applause from our own audience here. So thanks for that. And wracając do naszych gości online, dziękuję bardzo za udział. Cieszę się, że wytrwaliście tutaj z nami. Dziękuję bardzo za ten udział. Przypominam, do 3:00 powinny być maszyny dostępne dla tych, którzy chcą jeszcze sobie poklikać. Także dziękuję serdecznie. Zapraszam na nasze kolejne wydarzenia. Miłego dnia.